everyone, in this video I'll be solving integration by U substitution methods from A-level past papers. So let's get into it. So we have an integral with limits 1 by 2 pi 0 and 0. 9 is a constant, so I'll take it outside the integral. So we have sine 2x and root of 4 minus 3 cos x dx. We're asked to use the substitution u equals to 4 minus 3 cos x. Okay, 4 minus 3 cos x. So first of all, what we're going to do is we want u to be instead of x, right? You can see x is here. We don't want x, we want du for that, okay? So instead of dx, we want du. We don't want sine 2x, we don't want 4 minus 3 cos x, we want u, we'll keep u in that place. Even the limits that you can see over here are going to be changed because these are x values, all right? So we'll start with changing the limits first, okay? So I'll write over here limits, all right? So the old limits, right, where x equals to pi by 2 and x equals to 0, okay? Now the new limits, the one that we're going to use right now, are going to be, first of all, u equals to, let me rewrite it, 4 minus 3 cos x, right? So we're going to just insert x values, right? And we'll find our new limits, right? New limits that are u. Okay, so 4 minus 3 cos pi by 2 and u equals to 4 minus 3 cos 0. Okay, so this is going to be u equals to 4 and u equals to 1. So these are our new limits. All right, these are the new limits. Okay, so now we'll write 9 with the new limits 4 and 1, and we still have sine 2x. Okay, now we can change. We know that u equals to 4 minus 3 cos x, right? So we already know that, so we can write, instead of 4 minus 3 cos x, we can write u now, so that u will be inside the square root, right? So that's what it is. Now what we need to change is basically dx, right? We need to find du instead of dx. Like in terms of du, we have to write it, okay? Dx. So we're gonna write dx in terms of du. So we have du, we have to differentiate u for that, right? We'll write du by dx, that is equals to 4, differentiate 4, it will be 0, then minus 3 cos x. So cos x, if you differentiate, you'll get minus sine x, right? So you'll get basically du by dx equals to 3 sine x, all right? So now your dx value will be du by 3 sine x equals to dx, all right? So instead of dx, instead of that, you can write now du by 3 sine x, all right? So now we have almost like the new limits. Then we have du with dx in terms of du, right? So now this sine x that you can see is an x term. Sine 2x is also an x term. So how can we get rid of that? We need to get rid of those terms, like x terms, and put it in u term, right? So we know that sine 2x equals to 2 sine x cos x. All right. So sine, 1 minute. Yeah. So sine 2x is equals to 2 sine x cos x, right? So what we can do for that is we will replace that, okay, and write sine 2x and cos x in, no, sorry, 2 sine x and cos x, right? 2 sine x and cos x. That's going to be divided by u du by 3 sine x. So now what we can do is that we have numerator, in the numerator also we have sine x, and in the denominator we have sine x, so we can get rid of those two, right? So now what you will be left with is basically 2 is constant, so you can take it outside the integral. That's gonna be 9 by 9 into 2. Okay, so cos x. Okay, so cos x is what is left in the numerator, and you have u to the power of 1 by 2, so I'm just changing it. It's basically root of u is equals to u to the power of 1 by 2, all right? So then you have, this is also a constant, so you can take it outside the integral, right? So you can take it outside the integral, so that's what I'm going to do. So that's going to be over here, all right? And now we have du, and sinus cancelled, so we just have now cos x to be u, right? Cos x, we'll have to write it in terms of u. So when we started the question, we read that that u equals to 4 minus 3 cos x, right? We want to make cos x the subject, right? So that's what we're gonna do. We're gonna bring this here, right? So that's gonna be 3 cos x equals to 4 minus u. Cos x is gonna be equals to 4 minus u divided by 3. All right. Okay, so basically this is the integral, and we have 4 and 1 as the new integral, new limits, and cos is basically 4 minus u divided by 3, and there was u to the power of 1 by 2 already present, so that's also going to be there in the denominator. And what you have du, this is 9 into 2, 18. 18 divided by 3, which is 6. 6, okay, so now let's scroll down. You have done your U substitution. Now you'll have to integrate right now. This is again a constant, right? This is again a constant, so we'll remove it and we'll make it, it's going to be 6 divided by 3, which is 2, right? 4 and 1, you have 4 minus u divided by u to the power of 1 by 2 du, which is also equals to this. Okay, so I'm going to split it right now, and I'll make u divided by 4 divided by u to the power of 1 by 2 minus 4 divided, u divided by u to the power of 1 by 2 du. That's going to be equals to, finally, that's going to be equals to 2. 4 and 1 is the limits. 1 by 2 minus 1 by 2, remember, and u 1 by 2 du. Now it's going to be very simple, easy for you to integrate. You have 4 and u to the power of minus 1 by 2. Okay, so minus 1 by 2 plus 1. Okay, that's going to be divided also, right? you'll divide this 4 and u with u to the power of 1 by 2 plus 1 with minus 1 by 2 plus 1. Alright. Similarly, you will have 1 u to the power of 1 by 2 plus 1. Divide that also with 1 by 2 plus 1. Okay. So this is you have done your integration, and the limits you'll have to apply, and the constant too, you'll have to multiply it with that. So basically, if you clear it up, you'll get as 4, okay, you'll get u to the power of 1 by 2, and you will get by 0.5, which is 8, right? And you will get over here u to the power of 3 by 2, and 1 divided by 3 by 2, that's going to be 2 by 3, right? That's more better. Okay. So now you will have to just insert the limits 4 and 1 in u, and that's what I'm going to do right now. This one is 22 by 3. Okay, so it's going to be 2 multiplied by 10 by 3, which is equals to 20 by 3. And this is your answer. Okay, for this question, it's worth for 8 marks. So if you follow all these steps properly, limits, you have to change the limits, right? Find the new limits, then change the x, right? Write dx in terms of du. So this is another important step. And then you'll have to, of course, write instead of 4 minus 3x, you'll write u, and sine 2x, you'll have to expand it, and you'll write 2 sine x cos x, right? And you will have to see if there are some terms that you can cancel, you'll cancel it. And you had x over in this question, you had cos x left out. So basically, from the limit that we were given, right, we found it out from the limit that we were given, that like we found cos x, and we wrote it in terms of u, and we wrote cos x in terms of u in the integral. And that's how we evaluated this integral, and we found the answer to it, right? Exact value of this answer. And that is 20 by 3. All right, this is another question we have, and it's worth for 4 marks. We have I equals to 1, 0 are the limits, okay? X to the power of 1 by 2 divided by 2 minus x to the power of 1 by 2 dx. So first of all, we're given u, right? We're told that u is equals to 2 minus x to the power of 1 by 2. Okay, so we know now that we'll have to change dx and write it in terms of du, right? And that's what we're going to do first. So du by dx is equals to, okay, so that's going to be 0 minus, and okay, so x, okay, 1 by 2, you'll multiply it with the coefficient of x, which was 1. Okay, so x to the power of 1 by 2, okay, so 1 by 2 plus minus 1, sorry, minus 1, okay, so that's going to be du by dx gonna be equals to minus 1 by 2 x to the power of minus 1 by 2. So basically, if you bring it down over here, that is gonna give you, that's gonna be to the power of minus 1 by 2, and you can bring it here because it was minus 1 by 2, so you can bring it and make it x to the power of 1 by 2 in the denominator, right? Now we know that u, okay, we'll do that later. So 2x to the power of 1 by 2 du is equals to dx, all right? Fair enough. Now we'll have to put that in this integral. Okay, so let's start. I'm not going to write the limits right now. So we have basically x to the power of 1 by 2 divided by 2 minus x to the power of 1 by 2. So instead of writing 2 minus x to the power of 1 by 2, now we know that it's u already. So I'm just going to write directly it's u. Now we use this, right? This one. So we're going to write 2x to the power of 1 by 2 du. Alright. So our form is basically they want it to be like this, right? Alright. So we need to know that what is x to the power of 1 by 2, right? We have 2x to the power of 1 by 2, so we want to find that first. Now, this, we have x to the power of 1 by 2 here, and we have x to the power of 1 by 2 here. So let me write, so u equals to, I'll write it here, u equals to 2 minus x to the power of 1 by 2. So if you bring x in this side, it's going to be x to the power of 1 by 2 equals to, and u in this side, right? 2 minus u. That's it. So basically, you have instead of x to the power of 1 by 2 in this one, you can write 2 minus u. All right. And you have 2 this here, right? Keep it there. All right. So multiplied by 2. Okay, multiplied by. Just keep it there. It's fine. And you have another x to the power of minus 2 that's here, right? This is also x to the power of minus 2, and we know what x to the power of minus 2 here, right? That is equals to 2 minus 1 u. So we're going to write that again, 2 minus u, okay? And you have du and you have u as well, okay? So now what we can do is that we can write I, then integral of that 2, you can bring it over here. You can see 2 minus u multiplied by it. You can multiply it with this, right? It's gonna be 2 minus u multiplied by 2 minus u, right? The brackets, right, in brackets. So it's gonna be basically 2 minus u squared. You're multiplying same things, right? They both are same basically. It's gonna be u. You're multiplying the same thing. This whole, both of them are same, so that's why it's gonna be 2 minus u squared. We have a u over here, so I'm gonna just directly write u over here, and you have du. Okay, so basically the whatever is inside the integral, we got it in the right form. Now we just need to find the limits. So let's write limits. So our limits were, all limits were x equals to 1 and 0. So our new limits would be, what is u equals to again? 2 minus x to the power of 1 by 2, right? So u equals to 2 minus x to the power of 1 by 2. So you'll have to insert each of the x values, and what are you gonna get? Basically 2 minus 1 by raised to 1 by 2, and u equals to 2 minus 0 raised to 1 by 2. That's gonna be 0 only. I mean, sorry, that's gonna be 0, so that's gonna be 2, and that's gonna be u equals to 1. So these are your limits. So you can write 2 and 1, right, as your limit. 2, 1, the limits, and 2 multiplied by 2 minus u whole square divided by u du. That's it. That's exactly the same form. Okay, so that's all for this video. If this video was helpful, please like the video and subscribe to my channel. Share this channel with your friends, and if you want me to solve other topics, do let me know. I will try my best to solve them, and I do solve from physics, chemistry, and maths, A levels and IGCSEs. So yes, if you want any help, let me know. I will try my best to solve them. And thanks a lot for watching.